In this sequence of videos, we're going to discuss the laws of logarithms. This will be a collection of rules for the logarithm functions, which are true because of how the logarithm relates to the exponential. So what I'm saying here is if you have the exponential, you could have any base here, but I'm going to put e, and you do e to the a plus b. Well, that is the same thing as not a, but e to the a times e to the b. And from this, we'll see there comes a logarithm rule. There's also logarithm rules for things like e to the a times c equals e to the a raised to the c. This is a property of exponents that has a corresponding property in logarithm land, if you will. Let's go ahead and just state the first few logarithm rules here. So we have when you take the logarithm of base a of capital A times b, then in this first rule what we see is that's going to be the same thing as log base a of capital A plus log base a of capital B. If instead of multiplication of capital A and capital B you do division, then you replace the addition with subtraction. And logarithms have this rule that if you have an exponent, the exponent can fall down in front of the logarithm, as Rule 3 says. Now, before we go on and start using these laws of logarithms, what I'd like to do is I'd like to show you with a specific example why number 2 here is true. So what I'm going to do here is I'm going to let capital A and capital B be specific numbers. I'm going to let lowercase a be whatever. I'm not going to replace it with a specific number. And I'm going to show that this rule in number 2 is true. And while I do that, maybe you want to try to figure out how how rule 1 is true as I explain how rule 2 is true. The reason I suggest that is because you do something very, very, very similar to explain why rule 1 is true. Okay, so what I'm going to do and how you can go about doing this in an easy way is I'm going to set capital A and capital B to be numbers. I'm going to pick 2 and 3. And I'm going to set this quantity equal to x. I'm going to set the quantity log base A of 2 equal to y, and log base A of 3 equal to z. And what I'm doing here is I'm setting up rule number 2 with capital A equal 2 and capital B equals 3. Now you could pick different numbers, that's fine. In fact, you don't have to pick numbers, you could leave capital A and capital B, but I think picking particular numbers maybe makes it a little less complicated to explain. By the way, if you're working on part 1 as you go, you might want to, instead of doing 2 divided by 3, do 2 times 3 in this first line here. And everything else you would set up exactly the same. And my goal right now is to convince you that x is equal to y plus z. Now the reason that this is my goal is because I'm trying to explain to you that number 2, rule number 2 here, is true. Well, what does rule number 2 say? It says that, well, this left-hand side is x, this left-hand side is x, and this right-hand side is, oh, I guess that's not plus z, but minus z. It is, this right here is y, and this right here is z. So let's go ahead and replace that plus with a minus, and let's try to see why is it true that x is equal to y minus z. Now, initially what I told you was these logarithm rules are true because of there's an exponential rule that makes them true. So instead of working in logarithm land, I'm going to convert into exponential land. So for star, what I have here is that 2 divided by 3 equals a to the x. That's just applying the definition of the logarithm. For the second entry here, 2 is equal to, well, a to the y. And for this third, we have 3 is equal to a to the z. All right, so now what I'm going to observe is I have 2/3 here, I have 2, and I have 3 here. That means if I take the second star and I divide it by the third star, I should get the first star. In other words, looking at these two here to the right, if I do the first one, 2, divided by 3, well, what will that get me? That will get me 2 over 3. And what are their right-hand side? Their right-hand side say 2 over 3 should be a to the y divided by a to the z. So this is a to the y divided by a to the z. And now with our exponential rules, we know that this is a to the y minus z. So this comes from the two right equations, just taking this leftmost here and dividing it by this rightmost. And now, what about the one outside of the yellow box? Well, that tells me that 2/3 is a to the x. Okay, well, also 2/3 is a to the x, and these two things are equal, so that must mean that these two things are equal. A to the x equals a to the y minus z. Well, if a to the x is the same as a to the y minus z, that must mean that x is y minus z. Not y minus x, y minus z. That's exactly what I wanted to convince you of, that x was y minus z. Now that I explained it with a specific example, you can go through and you can replace all the 2's with an a, a capital A, capital A, capital A, capital A, capital A. You can go ahead and replace all the 3's with a capital B, capital B, capital B, capital B, and all of these will change as well. We had capital A in the denominator, capital A in the numerator, capital B in the denominator, and we would get at the exact same thing. So it's not just true for capital A equal 2 and capital B equals 3, but it's true for all capital A and all capital B. Well, almost all capital A and capital B. See, the only problem is we can't take a capital A and capital B, which we can't plug into the logarithm. Let's unclutter this a little bit. So, for example, if capital B was -1, can't plug -1 into the logarithm because the domain is all positive numbers. So I need A and B to be positive numbers here. I'd like to make another remark regarding sort of the language of some of the problems. So when you start with something that looks like the left-hand side and you make it look like the right-hand side, this is called expanding logarithms. We call it expanding because it tends to make the expression longer lengthwise. And when you take something from the right and make it look like something to the left, then we call that combining logarithms. And each is useful in their own separate applications. Sometimes it's useful to expand, sometimes it's useful to combine. So you need to know how to do both. But when it says expand, you move from left to right, make it. Let's do an example of expanding logs first. So I'm going to expand these two logarithms, and my advice